Stephen Jones is the HAS Vice President as well as the Astronomical League Coordinator, wears a number of hats, as I mentioned earlier here at the club. When he was 6 years old, his dad, Stan Jones, gave him a 60mm Tasco refractor and started trying to teach him to use it. He had a little bit of success, limited success at the time. His father looked for help and found HAS. I'm glad he did. Stan's efforts led him to take astronomy himself and acquired a 10-inch Meade Schmidt-Cassegrain telescope. Stan was a regular out at the dark site with Stephen enthusiastically along for the ride. Later in life, Stephen rekindled his interest in astronomy, and with a 6-inch Dob from the HAS Loaner program, but later a 10-inch Dob and a 16-inch Dob rebuilt using the mirrors from his dad's scope, he completed the requirements for the Master Observer Award. Stephen has also served 3 years as field trip and observing chair of HAS. He conducts novice labs, as we mentioned earlier, at the dark site, where he teaches the night sky and basics of using a telescope to those new to astronomy. So I am really looking forward to this talk, Stephen, and I'd like to pass the baton over to you. Thank you.
Thank you, Joe. Just give myself one moment to get my PowerPoint up here.
Yeah, and while you're doing that, for those of you who would like to ask questions of Stephen throughout the course of the conversation, please feel free to use the chat function that we have here in Zoom, and we'll keep a running list of those, and we'll get to those at the end of the presentation.
All righty. So, okay. All right, let's get this thing started. Okay. So everybody's seeing my screen now. Everything look good?
We see it fine, yeah.
All right. So hello, everybody. My name is Stephen Jones. Like I said, like Joe said, Joe gave a pretty good introduction to me, so I don't need to talk too much about myself here. But yeah, I've been in the club off and on for most of my life, and you know, I've always been a visual observer. You know, I've always thought about doing astrophotography, but it's just never really clicked that much for me. I thoroughly enjoy observing the sky with my eyes, aided with a telescope, but just, you know, soaking those photons in right through my eyeballs. There's something special about you know, light from millions of light years away coming straight into my eyes. So I'm extremely passionate about it. So that's why I bring this talk here to you. We're going to be talking about the art of visual observing and preserving your observations. Visual observing is where our hobby began. Human beings have been doing astronomy for as long as we've been doing astronomy for as long as we've been around. But astrophotography has only been around about as long as photography has, which has been not quite even 200 years. Astronomy, even when astronomy really got going, you know, these three guys on your screen, Galileo, Messier, Herschel, all these big names from the early years of astronomy were all visual astronomers. They were looking through their telescope with their eyes, just like we are. You know, no cameras, no fancy computers or anything. So in doing visual observing and observing the sky with our eyes, we are repeating the observations of these greats. And a lot of the Astronomical League programs that I mentioned are based on some of the observations that these guys made. There's a Galileo, Messier, and Herschel programs in the list of astronomical programs. Yeah, so that's what we're doing. We're you know, we're not necessarily doing a whole lot of scientific discoveries visually anymore, but it's in terms of the sheer enjoyment of it, just, you know, seeing what these guys saw. It's that's the heart of what astronomy is for me and for a lot of people. And here, just, you know, a little bit about myself, you know, just to give you an idea how long I've been in it. You know, the picture on the left there, that's my dad, Stan Jones, who Joe mentioned, with his Schmidt-Cassegrain. And on the far left of that picture is a 7-year-old me and my sister. I have no idea what we are doing in that photograph. But that's where I got started. And then the picture on the right is me today with my 16-inch telescope. Many of you have seen me out there with it. I'm bringing it out there again tomorrow. Feel free to come by and have a look. But yeah, both of these pictures, by the way, were taken at the HAS dark side. So we talk about visual observing. What can we observe visually? Well, I mean, we can observe pretty much anything visually, as long as it's emitting visual light. We're not going to be visually observing a black hole, but beyond that, we can visually observe anything that emits visible light. The sun, the moon, planets, comets, meteors, double stars, variable stars, and star clusters, nebulae, and galaxies. Those last three, which we would kind of collectively describe as deep sky objects, is primarily what I'm going to be talking about tonight. I'm not going to really spend much time on the other things, just out of time constraints. I could give several presentations if I wanted to cover all of visual observing. So I'm going to focus on deep sky. That's what I'm the most passionate about. I think it's what a lot of other folks in the club are also passionate about. And another thing that's important to mention, there's a lot of objects that you might not think could be even seen visually, that you'll be surprised they can be seen visually. Even though for the most part, most the scientific discoveries have been made photographically over the last 100, 150 years or so, there are still several objects that may have been discovered photographically that, believe it or not, can be viewed visually with a large enough scope from dark enough of a site. I have personally visually observed objects that were unknown to mankind as recently as the 1960s. It can, with the right equipment and practice, there's a lot that can be seen visually. I'll take a quick moment to talk about how to plan your observations. And this is one thing that I've found that a lot of people kind of miss out on when they're first getting started is choosing objects as high in the sky as possible. What do we mean by that? Why do we do that? Well, if you look at the diagram that I have on my screen, you'll see we got a little stick figure there in the middle. In the inner circle there is the Earth, the outer circle is the atmosphere. Pardon the art, I did this in paint yesterday, so anyway, but if you'll notice that when the stick figure is looking straight up, that distance to the edge of the atmosphere is a lot shorter than if he's looking horizontally toward the horizon. And what that means is that when you're looking closer to the horizon, you are looking through a lot more air than if you were looking straight up. So what this means for the more air you're looking through, the more difficulty you're going to have seeing your object, because all that atmosphere distorts what you were seeing. So now you're not always going to have a choice. Some objects that are far to the south, for instance, are never going to get super high in the atmosphere. For those, get them when they're at their highest point and deal with it. But let's say you have an object that its highest point is pretty high in the sky. You're not going to want to look at that object when it's over there on the eastern horizon. If that object is on the eastern horizon right now, wait a few hours, it'll be higher. If it's on the western horizon right now, well, maybe you're looking for it in the wrong season. Come back in a few months when it's over in the east, and then wait for it to rise higher and view it then. You choose your objects to view them when they're in the best place for viewing. But even over the course of a night, as the Earth is rotating and the sky is rotating, or the sky is apparently rotating around me, I will try to keep my observations as close to the central meridian as possible, just to make sure that I'm getting, at the very least, the best view I'm going to get of that object on that night, or close enough to it. So that's one of the more important things that a lot of people don't always realize about making the most out of your visual observing. And then the next thing about planning your observations is simply, what do you want to observe? There are a lot of different approaches to this. Some people like to pick a particular part of the sky, a particular constellation, and just run through that constellation and observe every object within those borders that they can. Me, I prefer to take a different approach. I kind of tend to target specific types of objects. I might spend the whole night viewing galaxies, or I might spend the whole night viewing globular clusters. And I prefer to do that for the most part, just because, I like to compare the objects to each other, see, what makes all these objects of the same class somewhat different or unique. And there's no right or wrong way to do it. You can do it my way, you can do it the constellation way, you can do it however you want. But yeah, figure out what you want to observe ahead of time, figure out where they're going to be, and go from there. The other thing that I wanted to mention in terms of planning your observations is having to do with the conditions. You might be familiar with the concepts of seeing and transparency being the two main parts of the conditions that we astronomers look for. Seeing, very quick definition of what it is. Seeing is the conditions of the turbulence of the atmosphere. So, if you have good seeing, the air is very steady. If you have bad seeing, you see a lot of roiling, a lot of waving, almost like kind of bubbling, almost like you see above the concrete on a hot day or something like that. That's what we're talking about with seeing. Transparency, on the other hand, is the clarity of the air. How clear is it? Is it dusty? Is it crystal clear? And so on and so forth. If we have good seeing, good seeing is what we want for fine details on bright objects. We're looking at the planets. We're looking at a very bright planetary nebulae. We're trying to see fine details. If we want to see the spiral arms in a galaxy, that's what we need good seeing for. Transparency, what we really need good transparency for is, lower surface brightness objects, large faint galaxies, large faint nebulae. For those kind of objects, we need the transparency to be as good as possible. Ideally, for the best observations, we want a night of both good seeing and good transparency. But we live near the Gulf Coast, and that means we almost never get both. We do get both every once in a while, but it doesn't happen very often. And for me, I would settle for good one or the other, and I will use that to plan my observations, to pick my objects. I'm maybe not going to go after a whole ton of faint nebulae or galaxies on a night where I have bad transparency but good seeing. But on that same night, I might get phenomenal observations of Jupiter, of some high surface brightness planetary nebulae, globular clusters, the bright kind, not the ones with their almost entirely faint stars. But it's just to give you an example. So if you've got conditions where only one of those is pretty good, use that to choose your objects for the most success. And there are a lot of places you can go to get lists of objects. If you don't know what objects to look for, there are observing articles in Sky and Telescope every month. There are books of observing lists. There's Stephen James O'Meara has a great series of deep sky companions. One of them was on the Messier-Avish, one's on the Caldwell objects. Then he's got 2 or 3 more of just his own personally curated lists of objects. Those are great books. Don Pensack is a well-known amateur astronomer who's a very very prolific poster on cloudy nights. It has a 500 object list that is very highly regarded. And of course, there's the Astronomical League programs, like I mentioned earlier. You know, if you need an observing list, you don't have, if you don't care about the awards, then you don't have to go after the awards. But even then, the lists that go with those awards are a great way to tell you what to observe if you don't know. And if worst comes to worst, if you're out at the dark site and you don't know what to look at and I'm there, come ask me, I will assign you some objects. Numerous people on this meeting have done that before with good success, so feel free. So now we're going to get into kind of the meat of the presentation that I have for tonight, and it's you know, we're going to be talking a lot here about logging your observations, and we'll start with the big question of why log our observations. You know, I know there's a lot of amateur astronomers out there who, you know, don't really do this. My dad was not a big logger. He never really spent a whole lot of time writing down what he saw. But I personally am a big fan of it. So why do we do it? Well, for starters, it's a tangible record of your observations. You know, the astrophotographers, they have records of everything they've done. They have their images. What do us visual observers have? If we don't log it, then it's at worst lost. At best, it's just floating around in our brain, where it can easily get lost, even to ourselves as we get older, as some of the older folks may know. So yeah, logging your observations, it's a record of what you see, so that you don't have to remember it all. It gives you a frame of reference for your future observations. You know, on a number of occasions, I have observed an object and saw some interesting details, and I've been like, have I seen this object before? Did I see that detail last time? And I can check my logs and I can say, oh yeah, I did see that object before, but I didn't catch that detail last time. Interesting. Or yeah, I did catch that particular detail, which, you know, some of these details we're observing are quite fleeting. So, you know, asking whether you saw that last time is a good question, because if you didn't, well, maybe that speaks to your conditions, or maybe you just imagined it the first time. You know, so many different interesting things you can figure out by observing the same object on multiple occasions, and then actually having those records of your observations to go back to. The third point I have here is to track the progress of your observing skills. Another fascinating thing, and I'm going to get into a few examples of this in a minute, but as you become a better observer, you got to track the progress of how much better an observer you're becoming by looking at your past observations of the same object. Because as you become a better observer and a better logger, you will you'll actually start to notice that you're actually seeing more. You're seeing more details. You're seeing the objects better. You're seeing the objects in a more critical way. And of course, the Astronomical League programs. As if you are interested in the Astronomical League awards, you got to log those objects to turn in to get them. So, and again, I know that's not for everybody, but if it's for you, logging is something you're going to have to do. Yeah, so here's an example of growth in observing through logging, and these logs are not mine because the handwriting is much too good. These are from Craig Lamison. Is Craig on the call? He said he wasn't sure if he was going to be here, but he said if he was, he'd be happy to go over this himself. Is Craig on?
I'm not sure I see him on.
Okay, he said he wasn't sure if he would be, so I guess he's not. So I'll go through it. All right. So this is so on the left is a log of Craig's from when he just got started, It's, it's a little haphazard. He's got, he's talking about M6, the butterfly cluster, along with M7 and what he thought was the Tom Thumb cluster. And he tried sketching them a little bit, and he gave a little bit of some very, very short little descriptions of it on his page here. This is from 2013. And on the right-hand side here, this is Craig's log entry on the Tom Thumb cluster, which he wasn't even sure he saw on the log on the left. This is his observation of this object from last year, so about 7 years later. And you'll note he gives all sorts of details about the cluster in terms of which direction the stars go and how bright they are, and he gives a very detailed sketch below. You notice his sketch on the left is just about 7 or 8 dots that are all about the same size. And here he's got a much more elaborate sketch. He's got dots of different darknesses for the brightness and everything. So this is an example of how your logs can evolve over time. And I got one more example. This one is not sketch, but this is my own. These are my own observations of M13. Several years apart, and also with different telescopes, but also with a lot of growth in my own observing. 2008, I said very large, bright globular, some resolution evident. 2014, I came back to M13 again, and then I talk about it being easily resolvable, large and bright, irregularly shaped at the edges, kind of like an octopus. And then I actually classified it according to the Trumpler classification, which I'll talk a little bit more about later. And then finally, I observed it again last year. And oddly, I gave a very different Trumpler class. I don't know what that's about. Clearly, I looked at it a bit differently that time. But, as you see, my description is even more detailed. I've got it resolved to the core, although that, again, I'm using a bigger telescope there too. Then I talk about the spider pattern. I'm also comparing it to M5, which is another globular cluster. And I talk about, the directionality of some of the streams of stars coming off the core and all of that. So, you can clearly see as time goes on, I'm seeing a lot more in the same object. So how do we log our observations? What kind of detail do we want to put down? Well, obviously, we want to put down the date and the time and what object we're looking at. We want to talk about the weather conditions. The reason we put down the weather conditions is because, well, we need to be aware of how that may be affecting what we're seeing. If we don't see as much this time as we did last time, let's look at what we wrote down for the seeing and transparency conditions. Maybe if transparency was worse, maybe that has something to do with what we're seeing differently, or whatever. Anything like that. And I wrote down light pollution here also. It is light pollution can have a big effect on what we see. So it is also an important part of our logs to know where we're at. Are we here in the city? Are we at the dark site? Are we out in West Texas where it's even darker than that? It's important to note that as well, because that can affect what we see as well. And then lastly, we're going to put down, the meat of our observation is, our description of the object and/or, I should have put and/or, but I just put or, but a description of the object and/or a sketch. I know some observers, when they see the word sketch, they kind of freak out. They're like, I can't do that. I'm not an artist, blah, blah, blah. You know what? I feel you. Neither am I. My sketches are horrible. I still do it sometimes. Because a sketch does not have to be a perfectly artistic representation of exactly what you saw. If you have the talent to do that, clearly, that's a great idea. Go for it. I wish I had sketches like that of my observations, but I don't, because I don't have that talent. But sketching anyway what it will do for you is it'll at least, if your sketch looks even a little bit like what you saw, it can remind you of what you saw. But even though that sketch might not be that helpful to someone else you might show it to, or that's what I saw. But at the very least, it'll be helpful to you to know, okay, you know, I saw that particular detail. And there's a few of my horrible sketches scattered throughout this presentation, so you can kind of see what I'm talking about. As far as the seeing and transparency conditions, how you determined that, the seeing conditions, one of the more famous, one of the more common scales for seeing conditions is the Antoniotti scale. It's named after the guy who developed it. It was, I don't remember if Antoniotti is from the 17th or 18th centuries, but I mean, this is an old scale, but it still works still works for this purpose. You know, just, you know, 1 would be perfect seeing, you're not seeing anything quivering at all, and where 5 is, you know, it's so bad there's not even a point of sketching whatever you're observing. Transparency, different ways to do it. There's a device called a sky quality meter that I have not used one of those. A lot of club members have, or you could actually, I guess you, I don't even know how those work, but I guess you point it at the sky and they'll tell you how good it is or something like that. Or you can just go based on your limiting magnitude. You know, what's the faintest star you can see? That's another good way of measuring your transparency. Descriptions and, okay, I got a little bit ahead of myself, I guess, because I already touched on this first point. You don't need good artistic ability to produce a useful sketch. Record every detail you see. That's important. And I guess it goes with the third point here. Do not rush your log. You know, the longer you observe an object, the more detail you will see. And that's very important, because the longer you have your eye to your eyepiece, the longer you're not, you know, the longer you're not bothering your night vision by, yeah, even though at the dark side we require you to use a red flashlight because it doesn't have the same effect on your night vision as white light, it still has a minor effect. You know, when I turn even my red light on a little bit, it still kind of jars me a little bit. So I sit there at the eyepiece as long as possible, making sure that I see as much as I possibly can. And yeah, every detail you see, even if it's a minor detail, you know, it could be telling you something important about that object. So just, you know, record as much as possible. And yeah, important thing, do not rush it. You know, as the longer you look at it, you will see more stuff than you saw the first time. So now, okay, so what we're going to do now is I'm going to go through the various different types of deep sky object, and I'm going to run through examples of what kind of details those particular objects have that you'll want to look for depending on that object. And I'm also going to share a few log entries of my own of those classes of objects to give you some examples. So for open clusters, you know, the galactic star cluster, not the globular clusters, but just your open star clusters like the Pleiades, like the ET cluster, stuff like that. When you're first getting started, the first thing that you're going to want to look for with an open cluster is, you know, describe the pattern. Describe, you know, what shape what shape the cluster of stars forms. You know, look for pictures of them. Look for tiny little constellations in the stars of the open cluster. Yeah, and be as descriptive and imaginative as you possibly can. The sky is really the limit with how you can describe an open cluster. I once recorded in my log that a particular open cluster looked like Patrick Star from SpongeBob. And interestingly enough, I was kind of tickled to see that in one of Stephen O'Meara's books, he also referred to an open cluster as looking like Patrick from SpongeBob. And it wasn't even the same open cluster that I described that as. So I thought that was kind of funny. But yeah, just use your imagination. The other thing we look for in open clusters is, are there any colorful stars in them? There's a couple of open clusters where one or two of the stars are particularly red, and that kind of jumps out at you. So that's another thing to look at. And then when you get a little bit more advanced, what you can do is start seeing if you can classify the open cluster according to the Trumpler classification system, which I have here on the screen now. It kind of ranks them according to 3 different measures. How concentrated they are, how concentrated and detached from the surrounding stars they are. What is the range of more than 100 stars? Those three particular measurements are, that'll tell you. That'll tell you just about everything you need to know about the cluster, other than, as I mentioned before, anything about the interesting shapes and whatnot. And here's an example of an open cluster log from my own logs. This is NGC 6596. I made this observation this past June from the dark side. Description: large open cluster near M18, larger than M18 but with much fainter stars. You'll see that I noted a picture here. Cluster is somewhat in the pattern of a club from the playing card suits. I distinctively saw 3 lobes of stars, kind of like in that club shape. So that's what I wrote down. And then I talked about what direction the stem points to, how many stars we have. I didn't actually write. I sort of touched on the Trumpler categories, although I didn't actually give it a number. But so that's an example of what a good log of an open cluster looks like. Globular clusters, like with open clusters, talk about the size, talk about the shape. You're not going to necessarily see a ton of pictures in globular clusters like in open clusters. You've got so many stars. There's a few exceptions though. But is it round? Is it somewhat elongated? You can rank it according to the Shapley-Sawyer classification. 1 to 12, just how concentrated it is. You noticed in my logs of M13 that I showed a few slides back that in the latter 2 I actually tried to do that and came up with a different value each time. Not sure why that happened, but it happens. And then how well you're able to resolve the cluster into stars. Does it just look like a snowball in your telescope, or do you actually see a whole bunch of different stars? And you'll also see on the screen right now, you have my terribly awful sketch of M10. I didn't even try to put a bunch of dots. I just kind of scribbled a bit of what shape the cluster was in to me. The main reason I wanted to draw this one was to bring attention to those 3 little prongs pointing downward. I felt like the stars on the bottom end of the field in this sketch, it really were kind of in 3 separate little lines of stars coming out of the core. I thought that was fascinating. So that's what possessed me to do a sketch, because I wasn't even trying to do. I wasn't even setting out to make any sketches that night. But I thought, this is interesting. I don't know how I'm going to describe this very well in just a verbal description. I'm going to make a sketch. And now that I have that sketch, now I'm going to know, that's what M10 looks like to me. And here's another description I gave without a sketch of M9. This was done just a couple of months ago at the dark side. And for this one, I said it was a small globular cluster, quite bright, resolved all the way to the core. but it was very concentrated. Gave it only a 3 out of 12 on the Shapley-Sawyer scale. That's on the concentrated end. And what I found fascinating is I wrote that there seems to be a void or fainter area on one side of the cluster near the center. I don't recall ever seeing that in a globular cluster before, so I made sure that I wrote down that detail. And just to make sure that I wasn't seeing things, that night at the dark side, I walked around a bit. I'm like, hey, if you get a second, check out M9 and see if you see a little dark area there in the middle of the cluster. And just about everybody I talked to saw it as well. And in fact, when I got home and looked at my logs, sure enough, it determined I had in fact logged that void in the middle of M9 before, and I had just forgotten all about it. So once again, there's another point for logging your objects. Moving on to planetary nebulae. Planetary nebulae, those are, these are the nebulae that are the remnants of dead stars. Usually, planetary nebulae are usually of a couple of specific shapes. The shapes that you want to look for in a planetary nebula. Is it round? Is it double lobed? Are there ansae? What that means, I think that's Latin for ears or something like that. But some planetary nebulae have projections coming out of either side of it, opposite of one another. Does it have multiple shells? Are we talking about multiple rings on the object or any sort of other internal structure? Is it annular or ring shaped? There's a lot of ring shaped planetary nebulae. The ring nebula itself is one of many. Is the central star visible? A lot of planetary nebulae, the white dwarf that is remained after it's shed all those outer layers into the nebula it's still there in all cases. Is it still bright enough to be visible? Many of them it is. And then of course, if you have an oxygen 3 or UHC filter, use it on that planetary nebula. Note the differences. What does it look like with? What does it look like without? How well does it enhance it? Does it enhance particular details? That sort of thing. You can get all sorts of detail out of a planetary nebula just looking at these particular details and using the filter. Here we have my description of NDC 7009, the Saturn Nebula. This observation was not made with my 16-inch. This was made with the C14 in the HAS observatory. You'll see that I cranked up the magnification to 559 magnification. I don't advise such high magnifications on very many objects, but bright planetary nebulae are among the few deep sky objects that can take that high of a magnification. On this occasion, I did do that with the Saturn Nebula. I said it looks very bright, takes high power very easily. Looks like a defocused Saturn oval disk with a nebulosity surrounding. Vivid blue-green in color. Most deep sky objects you are not going to see color in. Planetary nebulae, again, are an exception to that as well. Some of the bright planetary nebulae will give off a very obvious blue-green color, and different shades of it too. So be sure to note that if you happen to spot it. The Saturn Nebula does have a couple of very thin ansae, which were not visible at all times, but in the moments when the seeing settled down, they popped into view. I did not see the central star. The nebula responded very well to both the UHC and O3 filters. I didn't know anything specific about that, but it just looked, so I'm guessing that it just kind of made the whole thing stand out better. And so that was a log of a bright planetary nebula. Here's a log of a faint planetary nebula. Abel 82 observed this object from the dark side in my 16-inch Dobson. You see, I'm only using 70 power. This is a much larger and more diffuse planetary nebula. What I said was it's a fairly decent sized disk. that it was barely visible with direct vision with the O3 filter, but I mostly used averted vision. Without the filter, I could not see it at all. I mentioned that it was possibly annular. And I also noted that the central star is visible only without the filter. So, yeah, you could see this without the filter, I could see only the central star. With the filter, I could see the nebula, but I couldn't see the star anymore. It was perfectly normal behavior, but I think this is the first time I noticed that it was that extreme. Usually, with the filter, the central star will be dimmer and the nebula will be brighter, or the other way around. But this was just, it was very night and day. I got one or the other. So I thought that was particularly interesting. Emission and reflection nebulae. These kind of nebulae have an endless variety of shapes, just like the open clusters. So use your imagination. And there are members of the club who have come up with very, very intriguing, descriptions for some of these nebulae. There are many nebulae with different names because different people name them different shapes. M17 was originally known as the Omega Nebula because that's what John Herschel described it as, looking like the Greek letter Omega. In later years, many astronomers today call it the Swan Nebula because it looks more like a swan to them. And a lot of us don't know what an omega looks like anymore either. I do, but not everybody does. And so the Swan Nebula is just kind of a more popular name for us today. And if you want a NSFW name for that nebula, talk to Brown. Anyway. But yeah, use your imagination when it comes to the Emission Nebulae. And like the Planetary Nebulae, try your filters. If it's a reflection nebula, the filters probably won't do anything. The Emission Nebulae, they should respond pretty well too. If you don't know which one it is, well, using your filters will tell you. And then you'll notice here my extremely crappy drawing of Barnard 33, the Horsehead Nebula. And the, actually, technically speaking, this is a drawing of IC 434, the bright nebula behind the Horsehead. But you see the nice big notch in the middle of it. That's the Horsehead itself. That's what it looked like in my 16-inch with the H beta filter. This is from this past January. This drawing doesn't do it that much justice, really, but I again, like I said, I have no artistic ability, but I drew it anyway because I wanted to record just kind of exactly where things were, if nothing else. And then here I have a description of another bright nebula that I also found particularly interesting. This is from January of 2020 at the dark side. This was the Hubble's Variable Nebula, which is a lovely, lovely object. I described it as being a cone-shaped or fan-shaped nebula. Tip points to the south and is star-like, surprisingly bright. I put that it seems brighter on the edges of the fan-shape than in the center, and that the effect was exaggerated when the filter is used, even though the filter overall didn't do too much for it. So, you can see just, there's so many different details that you can see in an emission nebula. Yeah, anyway, what's next? Galaxies. Yeah, galaxies, if you do a lot of deep sky observing, you're going to observe a lot of galaxies. Because number one, there's more of them than anything else, and they come in a lot of variations. But there are more subtle variations. Elongation, the degree of in what direction. Some are edge on, some are face on. Some of them, the only way you can tell that is by seeing, just are they round, are they more oval shaped? the brightness distribution. Some have a very bright core in the center that almost looks like a star. Some don't have that at all. You'll want to note that in your logs. Does it fade evenly or suddenly? Some galaxies, almost kind of look like a bullseye. You've got a bright center followed by an area around it that's a little fainter, followed by an area around it that's obviously a little fainter. You see, distinct zones. Other galaxies, it just kind of fades out smoothly from the center. That's another thing you'll want to note. Is there a dust lane? On bright edge-on galaxies, you can see a dark streak right across the core, and that's a dust line. You have a face-on galaxy. If you're using a larger telescope, if the seeing is good and the galaxy is face-on or close to it, you may actually be able to trace out spiral arms. There's not a ton of galaxies that you can do this with. It's mainly the brightest of them. The most obvious example is the one that I have a crappy sketch of here, which is M51 the Whirlpool Galaxy. It's a very distinctive and very, very clearly spiral-looking galaxy. I think everybody on this call who's ever seen it in the telescope before recognized it from my sketch, despite the fact that my sketch is crappy. But M51, you'll see it's got a nice bright center and kind of a dark area around it. And then the ring around the outside with the clear spiral arms going. The bottom one's kind of tapers off, and the top one connects to the companion galaxy, NGC 5195. I've got a few different descriptions of galaxies here, just to sort of give you variation. First is a recent observation I made of the Andromeda Galaxy. I've seen this galaxy many, many times, but for some odd reason, 2 months ago, I realized I had never actually logged an observation of it with my 16-inch. I'm like, what am I doing? So I made one. I just wrote this a very large oval with a bright core. Nebula actually stretches across the field, fading out toward the edges. I made a note of, I could clearly see both dust lanes. The inner one was very easily, and the outer one a little bit more difficult. I kind of logged the differences. I kind of logged the distance there, where they were from the center. NGC 4565 is probably the prettiest edge-on galaxy there is. Some might argue with me that the Sombrero Galaxy is, but I don't know. To me, 4565 is where it's at. Thin, flat galaxy, a central bulge, bright nucleus, and then the dust lane, very clear all the way from end to end. M101, I got very verbose with this description. This description of M101, I made this log out at the Prude Ranch in West Texas in May of 2020. This, I don't think it'll get quite this much detail out of M101 at our dark site. I talked about the core. I talked about being able to trace the length of 3 different spiral arms and both the directionality. And then M101, because it's face on and nearby, I was even able to point out a few kind of concentrations within the spiral arms, which are actually those are actually nebulae in M101. So we're observing objects in other galaxies here, and I just sort of I could read all this, but it's just it just gives you an idea of how much detail you can see with the right instrument under the right kind of skies. And then NGC 1365. This was one of my favorite recent observations, actually. NGC 1365. This was from about a year ago, and I was in the middle of observing the Fornax galaxy cluster. I was kind of hopping around from all the galaxies in the Fornax cluster, and 1365 was the brightest member, but it was also the direction I was going through the cluster. It was actually the last galaxy I came to. and I could tell looking at it at low power, I was like, there's a lot of detail I'm seeing here that I didn't expect to see, because I've been looking at a whole bunch of really faint galaxies. So I cranked up the magnification, and I thought I could see the spiral arms. Like, I thought 1365 is a barred spiral galaxy. I didn't actually know any of this going in. But nonetheless, looking at it, I thought I could see a central bar, and I could see spiral arms. So I made a point of logging, okay, which direction is the bar? Which direction are the arms? And even though, sketching was the furthest thing on my mind on this night, but I had to, because I wanted to make sure I made a record of what I saw. And this sketch right here, this is what I saw. You'll note I didn't even bother sketching field stars. I just sketched what I thought I saw in terms of what the galaxy looked like. And not even knowing that that's what the galaxy actually was supposed to look like. I thought that's what I saw. And then when I came home and Googled it, I compared this sketch to Google images of the galaxy and was quite pleased with myself that I didn't imagine any of this. That's actually what I was seeing. So anyway, so now to take a few minutes about, okay, so how do you log your observations out in the field? You can write it down in a plain old notebook if you want, or there are notebooks that are actually made for astronomical logging. The Astronomical League has one you can order from their website. I thought I had it handy. I don't. But yeah, they have a logbook where every page is pre-printed with blanks for all the stuff I just told you need to write down. It has a little circle to draw your sketch in, and all of that. I haven't been using one of those, but like I said, recently bought it. I may start using it. Sky Tools. If any of you guys use the Sky Tools software, you can actually do your logs in the Sky Tools program. Part of the software is logging. So you can enter all your data into there. Of course, sketching. And the other thing I have here is a digital voice recorder. This is what I like to do. If I'm trying to handwrite a sketch out in the field, it's kind of distracting for me, because then when I have to keep taking my eye away from the eyepiece to write something down. Of course, I have no choice here with sketching. If I'm not sketching, if I'm just describing something, I don't like having to look away like that. And also, turning the flashlight on, it messes with my vision a little bit. And so I don't necessarily like to do that. So what I do instead, I have a digital voice recorder, and I think you can use your phones for this too, but I don't like doing that either because the phone screen has light. So I just have a cheap little recorder. But when I'm ready to log my observation, I will turn my voice recorder on while I'm still looking through the eyepiece, and I'll just dictate everything that I think I see right into the recorder. And then, later when I get home, when I have some free time, then I'll take my recorder out and I'll actually type up whatever it was that I had logged. Here we have a screenshot from Sky Tools, just to give you an example of what that looks like. See, there's all sorts of windows to fill in the various details, and you can even put a sketch in there. This is Craig Lamison contributed this sketch, this log screenshot as well. I'll just show you what that is. And the last thing I wanted to cover is just a few miscellaneous special techniques for your visual observing. Averted vision, real quick, averted vision, for those of you who don't know, that means, if you don't look directly at an object, if you look kind of to the side of it, you can actually see more because you have more rods not in the center of your eyes. You can see things better with averted vision than you can with direct vision. So when you're observing really faint objects, you can use a scale like this for averted vision. If you're observing an object that you can't actually see with direct vision, you can rank its averted vision level like this. Averted vision level 1. You can see it with averted vision. Once you found it, you can every once in a while see it with direct vision. AV2, you can see it with averted vision only, but you can see it steadily with averted vision. And then you go back to these other levels are we're talking about objects that you can't even see them unless you're looking away from them, and every once in a while you'll see it like pop up a few times. This is I haven't done a whole lot of viewing objects this faint, except when I've been looking at galaxy clusters, because I've at least got a couple of bright galaxies in the field of view. I look at them, then I might see some of these faint ones in the same field. In fact, I think I got this averted vision scale from the Astronomical Galaxy Cluster Program manual. Other techniques you can use, be sure to use different magnifications. I know some astronomers that just kind of stick one eyepiece in the scope and just keep bouncing from object to object. I don't like to change eyepieces that much, but every object is going to look better at a different magnification. Some objects look good at multiple magnifications in different ways. Different powers can yield different details. And sometimes higher powers can darken fields and reveal fainter objects. So if you have a bunch of eyepieces, use them all. Figure out which one makes the object look best, and then choose that magnification to stare at it for a while. But don't be afraid to try it at a different magnification, and don't be afraid to crank up the power. A lot of people who are new to this, a lot of people who are new to astronomy will automatically go for the high power, and they can't see anything. And they'll talk to someone who's been doing this for a while and say, "No, you want to use low power," and they'll look at it with low power. And they'll be like, "Oh, okay." But then from then on, they don't crank up the power anymore. So yes, use your low power most of the time. Definitely use your low power to find an object. Once you've got the object, crank it up and see what happens. If it looks worse, fine, go back to the low power. But you just might actually see something interesting at the higher power as well. And then of course, use the nebula filters if you have them. O3, UH3, H beta. These are somewhat expensive and specialized filters. You might not want to invest in them just yet if you're just starting out, but if you're into nebulae at all and you do have the funds, I would highly recommend those filters to anybody. And that's all I have for tonight. I will take any questions, but the last thing I just wanted to leave you with before taking questions is, for those of you familiar with the clear sky chart, this is the forecast for the Columbus dark site for tomorrow night. So hopefully you guys' calendars are clear. I hope to see many of you out there tomorrow. I will be out there tomorrow for sure, because there's a lovely forecast, and it's new moon. I'm not going to have any moon messing us up, so it's going to be a great night tomorrow. So I hope to see a whole bunch of visual observers out there. So now I will take questions.
All right, Stephen, thank you so much for the presentation. We did have a number of questions come up. Had a few about voting. I'll get to those once we're done here. But Peggy Mueller asked about differentiating between seeing and transparency. Peggy, did you want to come off of mute and clarify that any further? I think it may have been.
Yeah, actually, I think he covered it because he went through the seeing scales and the using limiting magnitude for transparency. So I think you did it. Thank you, though.
Oh, certainly. Okay.
Yeah, thanks for a great talk.
Yeah, thank you. All right, Jim King had also asked same equipment, and I think he might be referring to the different log entries that you had, whether you were using the same equipment. Jim, do you want to come off mute and clarify that?
Yeah, I noticed that early on that you were not indicating what you were using. Well, the equipment that you were using, but as you progressed, I saw that you would include the instrument and magnification and stuff like that. So you kind of answered my question.
Yeah. Most of those logs were done with my 16-inch. I think that one that I actually mentioned was done with the C14 may have been the only one that wasn't with my 16-inch.
Yeah, well, you had about an 8 or 10 year span there. So I was kind of curious in my mind if you were using that big horse of yours all that time, or were you graduating up?
I've been using primarily my 16-inch since about 2014. I used some smaller telescopes prior to that, but
some of those notes I saw for like 2006 and 2008.
The only 2008 one I had was on that slide where I was showing my progression. Yeah, that one was done with a 6-inch. But anyway.
But I just felt like that was probably important information that people should write down.
Absolutely.
If they're going to sketch.
You're absolutely right, Jim.
Okay. All right. And AJ Durrani had asked a question. AJ, do you want to come off of mute and ask? Not sure if he's still on, but he had asked how much of this function is a function of the telescope. I'm not sure in what context it was in. Maybe.
Yeah, I wonder if he may have been referring to the slide where I was showing the progression in my logs. He probably noticed there that I was also using a bigger telescope each time.
Yeah.
And so, I mean, to some degree, it is a function of the telescope, but it is definitely also a function of experience and logging attention to detail as well. If you're not trying to benefit from your aperture, you're not going to. I mean, it's, you will a little bit, but to see all the details, I mean, I don't want to pick on you, Joe, but you gave a pretty decent example yourself when you were mentioning our experience last weekend with your 25 and M33. So,
yep.
It's the telescope helps, but it's both, really. Yeah,
it really is. Yeah. Okay. Mark Meaverding had asked a question. Mark, do you want to come off of mute and ask the question that you posted in the chat room? I know you had some responses.
I think it was already answered in the rest of the chat, just using red light there.
Okay.
I'm good.
All right. For others, I guess the question was, how can you see enough to draw while in a dark site environment? And yeah, typically we use red lights, red flashlights on the dimmest setting possible. Some people have table lamps where they have an actual table that they'll use an observing chair to do their sketches on and whatnot. But the red lights are our friends out there in those dark locations. Stephen, anything else to add to that?
Yeah, and also, and I recognize also that it's not exactly those low light conditions, even with the red flashlight, is not ideal for producing a great sketch. But I can't produce a great sketch anyway. But for folks that do have the artistic ability to do so, it may be you may not actually be able to succeed at getting a great artistic sketch out in the field with the red flashlight. But you might be able to sketch well enough to remind yourself what it looked like. And then after you go home, in full light, you can look at your crappy sketch and compare that to what you remember. And then you can, at that point, create a better, more artistic sketch if you possess the ability after the fact there while it's still fresh in your brain.
Okay. Martil Luther had asked me to ask you, what do you mean by resolve in your logs?
Martil, are you talking about with regard to globular clusters?
That may be it.
That's where I use the word the most in my logs. So I'm going to assume that's what you're talking about. What I mean by resolve is, am I seeing it as stars, or am I just seeing haziness? So like a distant globular cluster, you might, or a nearby one, if you're using a very small telescope, might just look like a nebulous snowball. That would be not resolved. Whereas if you're actually seeing, hundreds, thousands of tiny little points, you're actually seeing individual stars. That's what I mean by resolved when it comes to a globular cluster. So,
Stephen, I'm going to share something, and it's not the best representation of it, but I remember seeing something on the Obsession Telescope's website. I don't know if folks can see that right now. Do you see it, Stephen?
Yeah.
Okay. So, and then again, this is just a representation, right? So, what you might see in an 8-inch telescope over here versus a 25-inch telescope. It's not quite like this when you're actually looking through the telescope itself, but when you're looking at the same object, on a good night with good seeing, good transparency, more light collection and power at the telescope, you'll actually be able to make out those pinpoint dots and stars within the cluster more easily. And I think that's what you're referring to, right, Stephen?
Yeah, exactly. I mean, resolve. Yeah, if you're seeing the individual stars, you're resolving it. If it looks fuzzy, you did. That's basically, yeah.
Okay. And then Bram was the last question that we had in the chat window. Bram, do you want to come off mute and ask the question that you had?
Sure. Question. Oh yeah, what are the little lines around the perimeter? And I think this was, you had one galaxy you were showing up there, might have been 51, and you had some little lines around it.
Okay, let me.
Were they maybe other galaxies? Because they certainly didn't look like stars.
Yes. Let me see here. You said you thought it was the M51 sketch?
Yeah. Or maybe it was the 4565.
You didn't see a sketch of 4565.
Oh.
This one,
Yeah.
Oh yeah, you have these big long lines.
No, like down in the 5 o'clock area.
Oh. Yeah, no, those are stars. They ended up like that because I'm drawing in the dark with a red light.
Ah, okay.
Yeah,
that's all that is.
All right. And I was going to look, okay, I don't see anything else at this point. So if anybody has any additional questions for Stephen, please feel free to unmute yourself and ask them of Stephen directly here. We'll take a few minutes to do that. While we're waiting for that, I just wanted to share my desktop again. And Stephen, you'd mentioned the sketchbook from the Astronomical League. I'm at the Astronomical League's website, their store function, and there's this visual astronomical observing journal.
Yep, that's it.
$16 there. 8.5 and 11 by 11-inch soft cover spiral bound observer's log and sketchbook. Includes 102 pages, 51 double-sided sheets, so on and so forth. So you can take a look at that. Again, you have to go to the store on the astroleague.org website, and I'm under charts and aids here on the left-hand side. The other thing I wanted to mention while we're waiting for folks who may want to ask some questions, I use these sketch sheets quite often. I just go to the website here and print them off. This is from the website of the American Association of Amateur Astronomers, astromax.org. And they have two different sketch sheets that they have here. The first one really is designed more for note logging, not sketching. So it'll have an area for the object itself, date, time, power, seeing, what instrument you're using, and notes over here up at the top. You've got your name, location, and whatnot. And then the other sheet that they have is very similar. It's got many of the same types of fields, and then it's got 2 circles drawn in there for any sketches that you may want to take. But you can do Google searches and find lots of different examples of these log sheets and whatnot that you can use out in the field. So I'll pause there. Did anybody have any questions that they wanted to ask of Stephen?
Joe,
Yes.
if you can call up the Astronomical League real quick. Why don't you pull up the observing programs for the new guys.
Yeah, absolutely. Bear with me.
Kind of give them an idea what we're talking about. Whoops.
Sometimes it just doesn't like it when I type it. All right. So, and we've had presentations on the Astronomical League observing programs before, as Stephen had mentioned. So for the members out there, you can go to the website and look at previous presentations that we've had, and you can follow them there. But if you go to the astroleague.org website, and up at the top here, you have this drop down for observe. When you go to that, you'll notice there's a menu item for observing programs listed alphabetically. You can also search for them by equipment needed or experience level. So some of these don't require any equipment at all. It's just visual observing. Some may only require binoculars, some do require telescopes. And then they also break them out by experience level. So some are really geared toward the very beginner in astronomy, others for more experienced astronomers as well. I usually come over here to the observing programs listed alphabetically. And in here, Stephen, I don't remember the last count. What are we at 80 something programs?
I don't know if it's that many, but it's ridiculous. Okay. They've come up with a program for anything.
Yeah, maybe it's like the 88 constellations, but they're all here listed alphabetically. Many of these give you the opportunity to earn a pin when you complete the program. I think most, if not all of them, give you the opportunity to earn at least a certificate. But you can come over here and find a particular program. Let's say the binocular Messier observing program. I can click on that, and in here it gives you an introduction of what the program is, why it was developed, and things like that. It has a list of the requirements and rules, and up here in the upper right hand section, just a quick chart. Most of these programs you'll see a quick chart like that has some of the more common aspects of the requirements listed there. And then to submit your logs for these observations, they usually give you the opportunity to either send them directly to the program coordinator. This is the person who from the Astronomical League does the coordination of this particular program. The best thing to do is, I think at least, and Stephen, correct me if I'm wrong, you could submit them to our own Astronomical League coordinator, who happens to be Stephen Jones. And what Stephen typically does, will give them a good once over and see if there's anything that might be missing before they're actually submitted. And if there's anything that needs to be corrected or clarified or anything like that, Stephen will let you know, and that way you don't send it off and wait for a little while, hoping that.
Yeah, and some of the more popular programs where they get a lot of submissions, this may be one of them. The person at the Astronomical League doesn't even actually bother looking at at your logs, unless you're a member at large. If you're a member of the club, they don't want to go all the way through your logs. They want me to do it for you.
Right.
So for like, if you do one of the more popular programs like the Messier program or whatever, I'm going to be the one reviewing your logs, not the person listed on the AL website.
Yeah.
So.
And then a couple things I just wanted to mention here that you got us on this topic, Jim, is Beyond Polaris is a great program for novices, people who maybe don't have telescopes. This is something that we've worked on with large groups here at the club. That's a really nice one. I know Stephen works on, or at least gets people started on the Constellation Hunter program, which is here for the northern skies, when he does his novice labs. And that's where, really all you're doing is sketching the constellations, if I'm not mistaken, Stephen.
That's all it is.
And then another one, the last one I'll mention here, Universe Sampler Observing Program. This does require a telescope to complete, but this one was actually developed by our own club member, Amelia Goldberg. So this is one that gives you a good, just like it says, a sampling of all the different things that you can see in the night sky with the telescope and with the naked eye, binoculars and things like that. So I'll pause there. Does anybody have any questions that they wanted to ask?
Joe, it looks like there was a couple more in the chart, in the chat, just about the Astronomical League programs. One said, can you use a single observation for multiple programs? Yes, provided that log entry fulfills all the requirements of those multiple programs.
Yep.
So for example, when I started working on the Globular Cluster program, the observations I had already done of some of the Messier objects in it, when I did my Messier log, I was not able to use again because I had not given the Shapley-Sawyer classification, which is required for the Globular Cluster program, but not for the Messier program. However, after I completed that Globular Cluster program, I did use several of those observations toward my Herschel 400 program because I had recorded enough for that program on the objects that are on both of those lists. And that I think that same person asked another question. If you logged your observations, could you submit historical observations? I think so. I think in some cases there may be a limit as to how old it could be. At the end of the day, every program has its own requirements. So generally speaking, the program that you're trying to work on, if you go to the website that Joe's showing you right now, click on that program, just read through all the requirements and it'll tell you everything you need to know. I'm happy to continue answering questions about that offline. Yeah, it's a lot of different answers for each program, honestly.
It really is. And Stephen, one of the things I wanted to mention is certain programs will not permit go-to method using go-to telescopes to get to the objects that you want to observe. So if the observations that you made use those go-to telescopes, then certainly with the Messier program, those would not be permitted for submission to the astronomical, correct?
Yeah, I believe the Messier program still requires star hopping.
Yeah.
The Herschel 400 recently dropped the requirement.
Thank goodness.
Yeah.
Okay. Anybody have any questions? I see a few hands raised. Hassan, you have a hand raised. Okay. How about Bram? Bram, I see your hand raised as well.
Yeah, I just wanted to throw out another tip. I used to struggle with dew on my equipment, my laptop, and if I was going to try to take notes or sketch anything, dew can be a foe there. But I guess it was last year I bought a little beach cabana, which is super lightweight. It was fairly inexpensive, very easy to set up. It just kind of pops up and just need to throw a couple anchors into the ground. And then you've got a nice shelter for all the paper and laptop to help protect it from the dew. Does a great job.
Perfect. Thank you, Bram. Appreciate the advice. Okay. All right. Well, if we don't have any more questions, we'll go ahead and get things wrapped up. Stephen, thank you very much for the presentation tonight. Really informative, and I'm looking forward to hopefully seeing everybody at the dark side tomorrow. I think, hold on, one more question. AJ Durrani had asked, can you give a brief preview of tomorrow's program? We don't have a program tomorrow. I think maybe referring to Stephen's comment about being out at the dark side.
Yeah, there's no program for tomorrow at the dark side. It's just, it's new moon and it's great weather, so a lot of us are going to be there.
Yeah.
So.
And that's a good segue to what I wanted to mention here. Our next meeting is going to be the Novice Meeting on Thursday, December 2nd. That's going to be the Thursday after the next Novice Lab. I think, Stephen, you said it's the last weekend, last Saturday in November. So immediately following.
Yeah, hang on. The Novice Lab, the next Novice Lab is, it is November the 27th.
Perfect.
So
Okay.
it's 2 days after Thanksgiving.
Wonderful. Okay. So we'll have our Novice Meeting on Thursday, December 2nd. We will have our general meeting on Friday, December 3rd. And I wanted to let everybody who's here know that I'm looking to see if we can actually have that particular meeting at the Trinity Mendenhall Center. Now that we're seeing kind of a downward trend with COVID hospitalizations and whatnot, we might be able to take some sensible precautions, keep safe distances and things like that, and have a number of folks join us at the Mendenhall Center. The one thing I want to do is make sure that we can still broadcast the meeting via Zoom the way that we're doing, so that we can have a component of it that's in person while live streaming everything to anybody who wants to watch remotely. So I will do some of that testing in the coming weeks, and I'll work with our program director, Don Selly, to make sure that this is something that can be done. And if it can, then we'll have at least a component of it at the Mendenhall Center. If not, then we'll revert back to what we've been doing for a year and a half, which is having the meeting solely held through Zoom. And then the last thing I wanted to mention was a few people had asked, where do we go to vote? Again, be logged into the website, astronomyhouston.org, and go to astronomyhouston.org/vote. And when you do, it'll bring you to this page where it says, do you approve of the displayed HAS leadership slate for 2022? And if you do, you can select yes over here. And if you don't, you can select no. And then once you've done this, and you're seeing me do a live vote, so I guess I will approve of the slate, hit vote, and it will take the vote from there. So please do that when you get a chance. We're going to keep the ballot open until next week, November 12th. And at that point, we'll take a look at the tallies and hopefully have a slate of candidates, or I shouldn't say slate, our leaders for next year. So, please get that done when you can. And that's it. So again, if you follow us, or if you have social media accounts, you could follow us at any of those links that you see there. Facebook, just search for Houston Astronomical Society. Twitter at Houston Astro SOC. Instagram, Astronomy Houston. And then YouTube, where a lot of our videos go to afterwards, Houston Astronomical Society. And as always, if you have questions, you can ask those at info@astronomyhouston.org. It's the same email address that you can send an email to if you want to get added to our special interest group. So I thank everybody for joining us tonight. Really appreciate you taking time on this gorgeous Friday night to be with us. And hopefully you got a lot of good information from Stephen, and you can enjoy the rest of the evening taking some of what he taught us and using that in practice. So, and if you can't do it tonight, then maybe you'll join us at the dark side tomorrow to do that as well. So again, Stephen, thank you very much. Really appreciate all the wonderful experiences and whatnot that you shared with us tonight. And we'll see you all soon. Take care, everyone.